students. In this class, we will be doing class 10 Samachir Kalvi syllabus or matriculation syllabus. So, first chapter I am doing relations and functions. In that already 3 exercises I have completed. Now I am doing the 4th exercise. In that 6th sum I am going to do in this class. Let A is equal to 1, 2, 3, 4. So, these are the 4 elements given and B is equal to N. N is natural number, starts from 1, 2, 3. Let F is a function from A to B defined by f of x is equal to x cube. Then find the range of f and identify the type of function. So, these two questions we have to find the answer. Okay. So, first one, B is equal to N, that is B is equal to natural numbers. So, we will take A as 1, 2, 3 and 4 and B is equal to N, that is natural numbers. B is equal to natural numbers and function is defined from A to B such that A to B and it is defined as f of x is equal to x cube. So, when we are taking x values as 1, 2, 3, that is natural numbers, if x is equal to 1, f of 1 is equal to 1 cube, that is equal to 1. Then x is equal to 2 if we take, f of 2 is equal to 2 cube, that is equal to 8. Then x is equal to 3, f of 3 is equal to 3 cube, that is 27. Then x is equal to 4, f of 4 is equal to 4 cube, that is 64. So, like this elements will be going on. That is, the function is given as f of x is equal to x cube. So, for all natural numbers, you have to find the cube. That is the function related. So, B is given as n natural numbers. So, this is the values you got for the function. Okay. So, first question is find the range of f. So, we are asked to find the range of f. So, range will be what are all the elements? What are all the elements that is connected with that is mapped to one element to the other element with some function, that is called range. So, the range for this will be 1, 8, 27, 64, like that it will be going on. So, that is range. Question is identify the type of function. So, we are asked to identify the type of function, so that we will identify using the arrow diagram. So, this is set A and this one is set B with natural numbers. So, set A is having 1, 2, 3, 4, 4 elements we are having. Since this is natural numbers we are having, we will be writing all the elements here. 7, 8, 27, 64. Since it is natural numbers, it will be going on and on. Then, this is related from A to B. It is, the function is related like this. That is 1 to 1, 2 to 8, 3 to 27, 4 to 64. So, one element in A has unique element, unique image in the next set. So, this is 1 to 1 function. So, one element in A is related to only one element in the second set. So, this is 1 to 1 function and the pre-image and the range is not equal. That is, codomain and the range is not equal. Second set is called all the elements in the second set is codomain, and how it is connected with some function, that is called the range. So, the range is 1, 8, 27 and 64. So, the codomain and the range are not equal. So, it is into function. So, 1 to 1 and into function. Okay. So, codomain is not equal to range. So, codomain is not equal to range. So, that is into function. Into function. Every element has unique element in. Every element has unique element, different images. Different element has different images. Unique images. So, this is 1 to 1 function. So, the given type of function is 1 to 1 into 1 to 1 into function. So, this one is 1-to-1 into function. Okay. Now next is in each of the following cases state whether the function is bijective or not. Justify your answer. So two sums are given. We are asked to check whether it is bijective or not. So what is bijective? If a function if a given function has both one-to-one and on-to, that is called bijective. One-to-one and on-to, if it is there, then it is called bijective. So that only we are asked to check. So here it is given f from R to R. R is the real number. So set of all real numbers to set of all real numbers. It is defined like that. So here the function is given as f of x is equal to 2x plus 1. Okay. So few elements we are taking. I am taking it as x. So those elements I am taking it as negative numbers and positive numbers I am taking. That is integers and some natural numbers I am going to take. So x is, first I will take x is equal to minus 2. So if f is equal to minus 2, then the function here, when I substitute it here, I will get minus 3. Then if x is equal to minus 1, then f of minus 1 is equal to 2 into minus 1 plus 1. So that is minus 2 plus 1, that is minus 1. Though then x is equal to 0, f of 0 is equal to 2 into 0 plus 1, that is equal to 1. Then x is equal to 1, f of 1 is equal to 2 into 1 plus 1, that is equal to 2 plus 1, that is 3. Then x is equal to 2 means f of 2 is equal to 2 into 2 plus 1. So that is 4 plus 1, 5. Okay, so we will represent this in the arrow diagram and check whether it is bijective or not. So first both the elements are R, both the set are R. So in the first set I am taking minus 2, minus 1, 0, 1, 2. These are the elements I am taking. And in the second set I am taking it as minus 3, minus 1, 1, 3 and 5. So this minus 2 is mapped to minus 3. Minus 1 is mapped to minus 1. 0 is mapped to 1 with some function. Okay, then 1 is mapped to 3. 2 is mapped to 5. So this one is function from R to R is defined by f of x is equal to 2x plus 1 is bijective. How it is bijective? It is 1-to-1. So distinct elements in the first set is mapped to distinct elements in the second set. So it is 1-to-1 function. On-to is range and the codomain are equal. So it is on-to function. So the given function has both 1-to-1 and on-to. So it is bijective. Okay, so the same way we will check the second sum also. So the second sum is f is mapped from R to R. So here also the same few elements I will take. So x is equal to minus 2. If I am taking f of minus 2 is equal to 3 minus 4 into minus 2 the whole square. So this will be 3 minus 4 into 4. So 3 value will be 16. So this, f of minus 2 value will be 3 minus 16. So 3 minus 16 is minus 13. Then if x is equal to minus 1, f of minus 1 is equal to 3 minus 4 minus 1 the whole square. So this is 3 minus 4. We get the value as minus 1. Then if x is equal to 0, f of 0 is equal to 3 minus 4 into 0. So f of 0 value will be 3. Then if x is equal to 1, f of 1 is equal to 3 minus 4 into 1 the whole square. So this is 3 minus 4. The value is minus 1. Then x is equal to 2. F of 2 is equal to 3 minus 4 into 2 the whole square. So this is 3 minus 16. that is equal to minus 13. So here, when we are checking this with the arrow diagram, so this is related, this both the sets are R and R. This is R and this is R. The elements, if you take minus 2, minus 1, 0, 1, 2 for the first set, and the second set minus 13, minus 1, 3, minus 1, minus 13. So this 2, minus 2 is mapped to minus 13, and minus 1 is mapped to minus 1, 0 is mapped to 3, and 1 is mapped to minus 1. Again, since only one time if we write, that is it, enough. So 1 is also mapped to minus 1. 1 is also mapped to minus 1, and 2 is also mapped to minus 13. So here, this is not one-to-one function. Why this is not one-to-one? Different elements in A does not, that is in the first set, does not have different elements as the image. So, this is not one-to-one function. Since this is not one-to-one function, it is clearly, we can say clearly that it is not bijective. Okay. So, with this, I am completing today's class. So, the remaining sums I will do it in the next class. So, whatever doubts you have, you message me in the comment box.